charger. Clear, guys? So we're done. So let's start the session. And in the last class, we are discussing about the boosting techniques. And within the boosting techniques, we are discussing about yesterday we have completed the ADA boost. And in the today's class, we are going to see the next type of boosting technique called as gradient boost and XGBoost. Okay, these both of them we are going to cover in the today's class. Right? So in the last class, I have told you how the ADA boost concept works, right? Where it is going to a combination of multiple decision trees. It is a combination of multiple decision trees where each decision tree was pruned with maximum depth of 1, which is called as stumps. So ADA boost consists of stumps. So multiple stumps combination is called as ADA boost, right? By combining various stumps. So first it is going to take from the first one. Okay. So coming to this ADA boost, first we are going to have the initial first decision tree number 1, which is a stump, which is not fully grown. So partially grown and means half, it is a stump means where maximum depth is equal to 1. Obviously, there will be misclassification records. These misclassification records will be classified in the second one. These second one will be misclassified in the third one. Third one will be misclassified in the fourth one. So you are going to combine all the misclassified records. You are going to combine. You are going to combine like this, one by one. Like this, you are going to combine. So once you combine all of them, then finally you are going to get a strong learner, which can classify the data, right? So this is one way of doing the machine learning project. It is one way. This algorithm works in that way. Now coming to the second way, that is one more way of doing this combination of decision trees is called as gradient boost. Now, how the gradient boost is going to work? Let us understand how the gradient boost works. Now here, I am having the input variable x1, x2, and y. Okay, I'm having x1 and x2 and y. So just focus on this. I'm going to take a table. Don't write along with me. Just observe so that it will be easy to understand. And later you can write. First, you are going to take some x1 variable, x2, and your y variable. Okay, this is the normal original data. The original data was given to you like this. This is the original data. Now, for the original data, what we are going to do is first we are going to create the first decision tree. Whatever the data is there, we are going to take the first decision tree number 1. Now, in the earlier case also, we have taken the same decision tree number 1. But in the earlier case, what we have done is the first decision tree is a stump. This time, the decision tree is not a stump. The decision tree, at the same time, it is not a complete decision tree also. The decision tree, it is going to take in terms of how we are going to create a decision tree means here we are having with a maximum leaf nodes. Maximum leaf nodes will be between 8 to 32. Okay. So pruning, I have discussed about the pruning in the decision trees. If you remember, the pruning can be done in the multiple ways, out of which first one is by using the maximum depth. The pruning can be done by considering the maximum number of leaf nodes. The pruning can be done with respect to minimum number of samples in the split node. Like this, we are having different options. Out of the options, we are going to use the maximum depth option in the ADA boost. That is, maximum depth is equal to 1. Now, maximum number of leaf nodes concept we are going to use in the gradient boost. Okay, by using this, we are going to prune the decision tree. Okay, done. Decision tree was pruned. And once the decision tree was pruned, and whatever the decision tree is there, it is not fully grown. Whenever it is not fully grown, automatically it will also have some misclassification records. Again, once again, you are going to have some misclassification record since it is not fully grown. Now, using the first decision tree, what I'm going to do is I'm going to predict the answers using the first decision tree. Using the first decision tree number 1. Using the decision tree number 1, I'm going to predict the answers for each and every record. Up to here, it is common, right? So the first decision tree was pruned with maximum number of leaf nodes between 8 to 32. And once it has pruned, whatever the answers you have got, you are writing. Okay. Now, once you have written the answers, that is pruned data answers. Okay. Now, you are going to create the second decision tree. How we are going to create the second decision tree? The second decision tree is created based on the first decision tree errors. Errors of the first decision tree. Now, what are the errors of first decision tree? What are the errors of the first decision tree means? The errors of the first decision tree, first we are going to calculate the error. That is y minus y hat. Once we calculated the error of the first decision tree, first we have calculated the error of the first decision tree. Now, whatever the error I have got, this is the error. Okay. Now, second decision tree. Now, second decision tree was made between x1, x2, and y minus y hat variable, not by considering the original y variable. Now, we are working on the y minus y hat variable. So, now, once we have worked on the y minus y hat variable and we have created a one more decision tree, now again, I'm going to predict the one more time y hat by the second decision tree. And again, I'm going to have the y minus y hat. Now, this time, third decision tree. What are the third decision tree is there? The third decision tree is created based on what? The error of the second decision tree. Whatever the error you have got here, this error versus original data, x1, x2, comma, this one. And it is going to work on that. Just observe this. Here I'm having the x1, x2, and y. Now, initially, this is my output variable. This is the original data. So for this original data, what I'm going to do is I'm going to create a decision tree. A decision tree which is having the output of this one. Okay, output of this column. Now, input are there, output is there. Now you are going to create the first decision tree. Okay, created the first decision tree. And from that, you are going to predict the answers. Whatever the answers are there, you are going to make the predictions. Once you have done the predictions, you are going to calculate the y minus y hat. Whatever the model you have done, this is the by model 1 output. Model 1 output. And for model 1, whatever the errors are there, you are going to calculate the errors of the model 1. That is first decision tree. Now, if you observe clearly, sir, in the output variable, I'm having the numbers now because it is a continuous variable. Sir, continuous variable means it is a regressor problem, right? Yes, I'm explaining the regressor problem. Gradient boost regressor, how it works. I'm explaining the gradient boost regressor because the output is continuous. Same way, I will explain the gradient boost classification. Okay, both of them I'm going to explain. First, I'm explaining the gradient boost regressor followed by gradient boost classifier. Now, gradient boost regressor, first I'm having the output variable which is called as continuous variable. For the continuous variable, it is going to make the decision tree number 1. And from the decision tree number 1, it is going to predict the answers. And whatever the answers was predicted, it is going to have y minus y hat by the decision tree number 1, y minus y hat. So first we are going to have this error. What are the error? This is the original data, y. This is predicted data, and this is the error. That is y minus y hat. Now using your y minus y hat, now what you are going to do means you are going to create the second decision tree. Generally, decision tree means what we have to create? X1, x2, and y variable we have to create by using the x1, x2, and y. But here what we are going to do means we are going to create the second decision tree by considering x1 and x2 and y minus y hat, not based on the y, by considering this one as the target variable. This one as the target variable, we are going to predict. Why, sir? Why we are going to do that one? So we are predicting the close to the target. We are trying to reduce the error. We are focusing on the error and we are trying to reduce on the error. If you understand this logic very clearly, if you try to understand this logic, for example, if I want a good model, I want a good model. I can get a good model by increasing the accuracy, or by decreasing the error. Two options will be there. Either by decreasing the error also, I'll increase the accuracy, or directly I can increase the accuracy. Now, I'm trying to decrease the error. I'm focusing on this one. Whatever the error I'm having, I'm trying to decrease the error. If you observe, this is the error made by the first decision tree. This is the error of the first decision tree. And if I calculate my MSC or RMSC, if I calculate this one, I'm going to have some MSC value or RMSC value, something. Now my focus is to reduce the error rate. Whatever the error is there, that I want to reduce. For reducing that one, what is the technique they have developed is, instead of creating a decision tree model on the output variable, create an output on the error variable by using the error variable. So they have taken the x1, x2 versus y minus y hat of the DT1, decision tree 1. Whatever the error of the decision tree 1 is there, they have considered. Now, after this, by considering, again they have predicted. Using the second decision tree, again they have predicted. And after predicting, again they have calculated the error. What is the error? Now, they have got the error like this. This is the error of the decision tree 2. Now, again, what they have done? Now they are going to use again x1. Now x1, x2, and error of the, whatever the error of y minus y hat of the decision tree 2 is there, they are considering this one as the target variable. Again, they are going to create the one more decision tree. So the process will be continued till you get the minimum error. So first, your error is starting is here. Some error, huge error is there. Okay, by using your first decision tree, you got a error of this much of amount. Second decision tree, by using the second decision tree, you have got a error. By using the third decision tree, your error has been reduced. By using the fourth decision tree, your error still reduced. By using your fifth decision tree, error reduced. By using the fifth decision tree, suddenly your error has increased. By fifth one up to 5, error was decreasing. Up to 5, the error is decreasing. But from the sixth one, the error is slightly increasing. Now you are identifying up to which decision tree is a good one. So 5 decision trees is a good one, instead of going with the sixth one. So the same thing, whatever we have done in the degree of polynomial regression, as you slightly increases the degree, the error was decreasing. But if you suddenly increase the still more degree, what happens? Suddenly the train error is decreasing, but test error, you are getting a huge difference. So it is also going to do the same. Means in the back end, what happens means, first it will try with the first decision tree. After that, second decision tree. After that, third decision tree. After that, fourth decision tree. Like this, it is going to check one after one after one after one. Which of the decision tree is giving the least error, it will stop there. Right? Whenever you are applying the hyperparameter tuning, and if you give the number of estimators is equal to 1 to 100, first it will try with 1, followed by 2, followed by 3, followed by 4, followed by 5. Like that, it is going to check, and which combination till which number the error is reducing, that number it is going to give as the gridset CV output. By default, it is going to take up to 50. Okay, in the Python. In the Python, it is 50. But if you do it the manual calculation one by one, step by step, if you do the manual calculation, then till you get the minimum error, we are going to work. We'll stop when we have got the minimum error. How we can know that this is the minimum error? Either the answer should be 0. 0 means that is the least minimum error. Than that we can't get. So 0 is the least case. If you get directly MSC value is equal to 0 itself, no need of discussion. But if you have got the MSC value something of 1000, something like this 1000 you have got. Now what you are going to do? You are going to try one more decision tree. And later you are going to check whether MSC has reduced or increased. If the MSC is increasing, then what we are going to do? We are going to stop there only without considering the one more decision tree. Which decision tree will give the least error? Till that we will continue. Now coming to the classifier, how the classifier will work. Okay, this is regression model. Voice breaking. Guys, others, can you please confirm? Is my voice is loud and clear? Clear, right? Done. Now, this is in terms of the regressor problem. Now, if you go with the classifier problem, now it is going to focus on the misclassification rate. Means, first you are going to have same x1, x2 variable, x1, x2, and y. First, it will create the decision tree, a normal decision tree, but a decision tree which is pruned. Now, sir, first tell us the doubt. What is the first doubt is, you are having a data, sir. This is the data. In the data you are having, let us take like this, sir. Okay. First doubt. This is my first doubt, sir. This is the data. In the data, I'm having x1 variable, x2 variable, and y variable. Assume there are total 1000 records are there. Means rows are 1000. Columns are 2 input variables and 1 is output variable. Okay. This is the data, raw data, what they have given to us. I mean, trained data. Data pre-processing was done. Everything was done. This is the x train comma y train data. Assume. Now, if you use the decision tree, what happens? If you use the random forest, what happens? If you use ADA boost, what happens? If you use gradient boost, what happens? First, tell us the first decision tree. Forget about the second one. First, you tell about the first decision tree. What happens in each of them? Tell the what is the difference in the each of them. Right? Now, I'm having like this, ADA boost and gradient boost. Now, in the first one, what happens means it is going to take all the 1000 records, completely 1000 records it will take. And it will create the model and no pruning will be done. Entire 1000 records was taken. Records are complete. At the same time, no pruning. No pruning. Completely grown. No pruning. Simply to say there is no pruning. No pruning means, what is the meaning of this? No pruning means 100% train accuracy. That is the meaning. In one single decision tree, you will get the 100% train accuracy. No pruning. It is clear. First one decision tree. Now, in the random forest, what happens? First decision tree number 1. Here also multiple decision trees are there. Here also multiple are there. In the random forest, what happens? Out of 1000 records, it is going to choose randomly 50 records. First one is this. Random subset. Randomly, it has chosen the 50 records and it has created the decision tree. Again, where there is no pruning. No pruning is there. No pruning is common. But in this, no pruning is there. In this also, no pruning is there. Here, 100% of the data is considered. Here, how much percent of data is considered? Subset of the data is considered, not 100%. That is the difference between these two. And decision tree number 2. Again, it is going to take second subset, but no pruning will be there. But subset of data. Subset of data with no pruning. Here, now in this case, ADA boost, what happens? It is going to take the decision tree of 100%. Again, it is going to take 100% data, but 100% data with pruned. That is the difference. Decision tree itself pruned with maximum depth of 1. When it is pruned, 100% train accuracy, how you can get? When you get the 100% train accuracy, when the entire decision tree was done, fully grown, you will get the 100% train accuracy. But here it is not 100% train accuracy. Obviously, you get the error in the first one. The error was rectified in the second one. Slowly, multiple decision trees are there. All the decision trees are pruned, but taking 100% of the data. Data is 100%, but all the decision trees are pruned. Now, in this case, here also the same. Again, 100% of the data. It is not subset of data. 100% of the data, but pruned. In the decision tree, 100% of the data with no pruning. Here, 100% of the data with prune. 100% of the data with prune. Here, no pruning is there, but subset of data. Is it clear now? Difference? Here it is going to take 100% of the data. 100% of the data means 100% accuracy you have to get now. When you will get fully grown means 100% accuracy will get. But you are pruning now. When you have cut the tree, automatically it is going to reduce the accuracy. 100% accuracy will not be there. Because when you are having the entire data like this, when you prune, some of the plus, minus are there. Again, if you continue means 2 pluses you will get, 2 minus you will get. But if you cut this one, in this only if you stop means pluses will be there, minuses also will be there. Then how you are going to predict means with respect to which is having more number of categories, that one you are going to predict as the answer. So here you are not going to get the 100% accuracy in the first decision tree. In the first decision tree, you will not get the 100% accuracy. No 100% accuracy in the first one. No 100% accuracy in the second one. But if you combine them, you will get the good accuracy. Right? Is that clear? So in the gradient booster, it is pruned. In this also it is pruned. Sir, okay, sir, the difference is clear for us. Random forest, no pruning will be done, but subset of data, it is pruned with 100% of the data. That is the difference, right? Okay, clear. Now these two are same, na? These two are same, right? It is also pruned with 100% data. It is also pruned with 100% of the data. Then what is the difference? Pruning here will be done with maximum depth of 1. Pruning is done here with maximum leaf nodes between 8 to 32. The maximum number of leaf nodes should be 32. It should not cross with respect more than 32. That is the limit. Any decision tree, maximum leaf node should be 32. It can't cross that. That is the difference. The both are pruned only, but here the pruning is different. Here the pruning is different. Pruning of one technique gives a different result. Pruning of one technique will give a different result. In the hyperparameter tuning, separately for the decision tree, if you apply maximum depth as the concept and 1, 2, 3, 4, if you give, you'll see with respect to which is the maximum depth. If you separately do with the maximum number of leaf nodes separately, don't combine both of them separately. If you do separately, you will get a different answer. Now that answer is best, this answer is best, miss. Do you remember this decision tree? In the decision tree, we are having a normal decision tree. I'm saying about the normal decision tree. A general decision tree. A general decision tree, you are having like this. Assume this is the case. Let me draw one example. Okay, like this, I'm having the decision tree. This is a normal general decision tree. Assume. In this decision tree, now what is the depth of this decision tree? 1, 2, 3, 4, 5. 5 is the depth. This is the decision tree. In this decision tree, what is the depth? 5. In this 5, if I do the pruning by considering the maximum depth is equal to 4. By considering maximum depth is equal to 3. By considering maximum depth is equal to 2. By considering maximum depth is equal to 1. Means I'm applying the hyperparameter tuning. Hyperparameter tuning with depth of 1, with depth of 2, with depth of 3, with depth of 4, with depth of 5. And after doing the hyperparameter tuning, it has given me the best result is maximum depth is equal to 4 with 90% accuracy. This is the answer I have got. Keep this one side. Now, how many leaf nodes are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 leaf nodes are there. Now, this time I'm trying with the pruning by considering the maximum number of leaf nodes is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm applying this one by a grid set CV with respect to maximum number of leaf nodes. This time I have got the maximum leaf nodes. Max leaf nodes is equal to 8 with the accuracy of best accuracy of 92%. Now, which is best out of these two? By considering maximum number of leaf nodes as a hyperparameter is best, or by considering maximum depth is the best? Which one is best? Miss, by considering the maximum number of leaf nodes. We have observed that both of them separately. Similarly, here also the same. That is, ADA boost was done with one type of pruning. Gradient boost was done with respect to one type of pruning. The scientist, first they have invented the ADA boost. After inventing the ADA boost, why we can't do a pruning? Why we have to do pruning with maximum depth of 1? One student has asked like this to the scientist. Sir, why we have to do pruning is equal to 1 only? Maximum depth is equal to 1 only. If I do with respect to by increasing, accuracy also increasing. And he has invented a new algorithm. In that way, they have started the research. And while doing the research, they have created with one more decision tree by considering the maximum number of leaf nodes. Now, while considering the leaf nodes, again, they have observed with overfitting problem. Oh, this is again leading to overfitting problem. Then what I have to do is, if you are focusing on the accuracy, it is leading to the overfitting. If I focus on the error to reduce the error, and they have created an algorithm which will focus on the errors. So second decision tree was made on the first error, first decision tree misclassification rate. Now you are trying to reduce the misclassification rate. If the misclassification rate is reduced, means automatically accuracy increases. Simple. In that way, they have created the gradient boost. Now, after creating the gradient boost, they have observed with respect to, again, there is a problem with respect to the gradient boost. Individually, decision tree is reducing the errors. But when you have combined all of them, finally you are combining, boosting means you have to combine. Now, when you are combining them, again, it is leading to the overfitting problem. Oh, again leading to the overfitting, because all of them you are focusing on the train data, how to classify. You are not forgetting about the test data. So, for example, in this class, I am explaining something, means you are focusing on the today's class and what are the topics I am saying, and you are writing the notes. You are forgetting to see the after the class interview questions. Every time you have to see the interview questions for every topic. Interview questions on the decision tree, interview questions on the random forest, interview questions on the ADA boost, interview questions on the gradient boost. You have to check the interview questions and you have to test yourself. Training was completed in the class. Testing also should be done. Then only whether it is overfitted or underfitted, you will understand. In the class, one person says that, sir, I understand the decision tree very clearly, sir. Crystal clear, you have explained everything, and how to take this one, everything you have explained. Now, type the interview questions on decision tree. Type interview questions on decision tree, not for a data science. Interview questions on decision tree for a data scientist. For a data scientist, you add the word called as for data science. For every topic, you add as at the end for data scientist. Now, exactly for the data science interviews, in the data science interviews, what are the questions they ask related to decision tree, you will get. So what is the criteria for root node? What is meant by Jenny impurity? What is meant by information gain? How we are going to, what is meant by pruning? What is pre-pruning? What is post-pruning? When you are going to do the pre-pruning, when you are going to do the post-pruning. These are the interview questions list you will get one by one. And if you check all the interview questions and if you solve, if you're able to solve, then it is called as good one. No, sir, I'm not able to solve all the interview questions, but whatever I'm explaining in the class is clear for me, but interview questions I'm not able to solve, means it is called as overfitting. Means I have observed in other batch, one trainer, I can't mention the trainer name, but the trainer, what he has done is, he has not explained the depth of max or how it is working. Just he has told that boosting means the second decision tree will be created based on the first decision tree errors. And it will reduce the errors. Simple. He has closed the entire boosting in one class. Theoretical part and programming part, everything he has closed in one class. The entire machine learning was completed in 15 days. He has covered the more number of topics by including some other like big data or Spark or something. But none of them he has covered with depth. Everything he has touched. Means in the resume for us to write the list will be more. But interview, no stuff will be there. Resume will have more things. Resume will say that I know machine learning, I know boosting. But in the interview room, if someone asks the boosting, means no stuff. So I have observed the students in the lab. Morning hours lab will be there, right? In the lab, I have went to the lab to clarify for the doubts of my students. I have went to the lab. There some of the other batch students, other trainer students, they have came to me and they asked some questions. And I told that it is going to work on the Jenny impurity. Sir, what is Jenny impurity, sir? Jenny impurity, what are? Suddenly I have shocked. They don't know what is meant by Jenny impurity. Okay, sir, maybe he has told Jenny index. Let us take in a positive way. He has explained either Jenny should be high. Jenny should be high. Jenny is high means automatically impurity is low. Maybe he has explained Jenny, I thought, and I asked it is going to work on the Jenny. Sir, Jenny only we don't know, sir. Jenny we don't know, Jenny impurity also we don't know. Jenny you don't know, Jenny impurity you don't know. Then how the decision tree will be working? Sir, decision tree means it is going to have a 3-type structure. Starting from the roots, ending with the leaves. Any tree will have what? Starting with the roots. Base will be the root. What will be the ending? Leaf only will be the ending. Na? Fruits or leaves will be the ending. If it is not a fruits, it is a general tree means what is the ending point? The ending point is leaves only is the ending point. He has explained in that way, it seems. I thought, okay. So pruning, okay, just you apply the pruning and do the optimization. Pruning, what is this pruning, sir? They don't know what is technical word pruning, but they know hyperparameter tuning maximum depth. Means in the coding part, they are good. They're good at coding part. They don't know what is theory and how it is working and why we have to use that one. In which case we have to use which one? Nothing they knows. Then I have understand, oh, like this also students will be there. Because that particular trainer wants with respect to more number of things he wants to include in the syllabus. But not in depth. Everything by touching. Okay? Not in depth, in detail, not with respect to in detail. Right? So that is one way. Now, in that way, what happens? Why I have told all these things means now these students from trainer perspective, since trainer has not explained anything like that, at least students should ask that question. Now, why students are like this? I have analyzed means then I have understand that since students don't know anything, whatever the trainer is saying, they're believing. Oh, this is only subject they are believing. There is no mistake in the students. They're believing the trainer. Okay, since the trainer has explained only that part, they are also accepting only that part. Okay, up to here completed. Now, at least training part is completed. Testing part you have to see now. After the class, what you have done? Have you typed the interview questions on the decision tree? And in the decision tree, what are the interview questions are there? If you are not able to solve, next day you went to the trainer and have you asked the questions? Sir, these interview questions was not covered in the class. What is this, sir? Have you asked any questions like that? No, sir. Till now, we have not checked the interview questions. Why? Why you have not checked? Sir, my trainer has told that you have to see the interview questions only at the end. Otherwise, you will get confused, it seems, sir. Okay, at the end, you will see the interview questions. The batch will be closed. Now you'll get the more number of doubts. Who will solve them? If the topic was not covered, who will cover that topic? Simply, they're misleading the students. Right? Now, in my case, I'm saying that decision tree topic was completed. Random forest was completed. Boosting was not completed. So don't type the questions on boosting. Type the questions on SVM. SVM was completed long back, 4 days back only. Type interview questions on SVM. Type interview questions on logistic regression separately. Type interview questions on KNN. And some of the students are doing that one. They're testing both train accuracy and test accuracy. But some students are not checking that one, which will lead to the overfitting. What is meant by overfitting means in the class, everything will be clear, but in the interview room, nothing will be there. That is called as overfitting in the real life. In the class, if you feel that it is very clear for you and everything is nice means, in the interview room also should be very clear. But in the interview room, you are failing miss, which called as overfitting in the real life in terms of. So that we have to rectify. Is that clear, guys? Now, here the gradient boost. How the gradient boost works means in terms of how the gradient boost works means same as ADA boost, but here the pruning will be done with respect to by considering the maximum number of leaf nodes to from 8 to 32. Second, one more is it is going to focus on the errors of the first decision tree. It is not creating the second decision tree with respect to directly by considering the misclassification records. It is trying to reduce the misclassification rate. It is trying to reduce the misclassification rate. Every time every decision tree was created in order to reduce the misclassification rate. And since the gradient boost is having the overfitting problem, since it is leading to the overfitting problem, now see this one here, there is a formula, some formula like this. What is the formula meaning is, you are going to observe the multiple decision trees and you are going to combine all the multiple decision trees one by one. This symbol indicates that decision tree is called as sigma of h of x. What is meant by h of x means some, not h of x, f of x, whatever it is. Sigma of f of x. What is meant by sigma means sum of the decision tree. First decision tree, second decision tree, third decision tree, fourth decision tree, fifth decision tree, sixth decision tree. Every decision tree you are going to do the summation. Okay. Always the boosting is sigma f of x. Whereas bagging technique is not with respect to sigma f of x. It is independent to each other. There is no plus symbol between them. They are independent to each other. We are not going to combine them. We are not going to work. The second decision tree is not dependent on the first decision tree. Nothing is there. But whereas boosting, the second decision tree is dependent on the first decision tree misclassification. So it is trying to reduce the errors of the first decision tree every time. Right? Now, next coming is to the next one called as XGBoost. So how the gradient boost works means a loss function. We are going to optimize the loss function. We are going to reduce the errors. Why? By considering the leaf nodes. Instead of considering leaf nodes, why maximum depth? That algorithm was designed in that way. The algorithm was designed by considering the maximum depth. If you consider by maximum depth, what happens? If everything are considering same way, then why to create another one? For example, if I'm asking you to learn, I have shared you a material, some textbook I have shared you, and I ask you to learn from that material. Assume one person is going to learn from the page number 1. One person will learn directly whichever the page number is required. Directly he'll jump into that page and he will learn. One person will learn question and answer. He will not learn the topic wise. Directly question and for that answer. Question, answer, question, answer. He will prepare in that way. Now, which process is correct? Finally, miss, try all of them. Which process will give in the future for you? On the future, how you can remember? If you prepare question and answers, it might be satisfying temporary purpose. 3 of the methods are there. 3 different methods are there for preparation and taking the exam, before to exam. For example, tomorrow is the interview. For you, tomorrow is the interview. Assume tomorrow you are having the interview. Okay, data science interview. Now, one day before you have to prepare something. You want to prepare. Now, how you are going to prepare? One way of preparation is whatever the notes you are having from the notes from the starting page, like core Python. From where we have started, everything we are going to revise one by one. Everything we are going to revise. Not practice, revise. I'm saying revise, not practice. Practice means it will take so much of time. I'm saying just you are recollecting. 4 months back, whatever we have discussed in the class, just you are recollecting the things. You are just recollecting. In the sequential order, you are recollecting everything. This is one way. Before to interview, you are doing this is one way. One way of preparation. One way of preparation of this one is you are trying to focus whichever is you are very weak. That one only you are preparing. You are already you are feeling strong in that one, means you are not preparing that one. You are not even revising. You are only focusing on the weak part. This is second way of preparation. Third way, opening directly the Google. In the Google, we are typing the interview questions. In the interview questions, we'll get some questions. Question and answer, question and answer, question and answer. We'll prepare in this way. Question, answer, question, answer, question, answer. First website completed. Second website. Again, question, answer, question, answer. Like this, we'll prepare. This is another way. These are the different ways of learning. This is one way of learning. This is one way of learning. This is one way of learning. Now tell me which one is the best one, miss? For tomorrow's interview, you may get to hear what is the accuracy you are seeing. Accuracy means tomorrow's interview, how you are going to perform. But you are forgetting once you selected in the interview, later you have to work in the company also. In the working in the company means nothing but test accuracy. Train accuracy, test accuracy. Two are there. Now, two of them you have to focus, not one of them. If you focus on one of them only, if you prepare from the interview perspective only, then automatically it will lead to the overfitting. Simultaneously, you have to balance both of them. This is also important. That is also equally important. You have to balance both of them. This is the way of different types of learning. Which one is correct, which one is wrong is nothing is there. Now you are going to apply, try with this way, try this way, try this way. And in which way you are getting a good answer and you are able to remember for lifetime, that is the best one. And you are going to continue. Similarly, here also we are going to do the ML algorithm 1, ML algorithm 2, ML algorithm 3. I'll apply 3 of them. And which one has given me the best result, that one I'm going to use furtherly. Which technique has proved me wrong, that technique I'm going to delete. If this technique is wrong for me, this technique is wrong. So I will not follow this technique in the further. Never I will follow this technique because it has proved for me wrong. I'm saying about me. And my technique will go with respect to this one. Because when I have practiced, automatically I have made with respect to very strong at that time only. While practicing itself, I have made very strong. Some of them I might be weak. I have identified where is my weakness is there. And I'm rectifying that weakness one by one, step by step, where I'm going to apply the boosting technique. Every time the weakness I'm identifying, the weakness second time I'm rectifying. Again, weakness will be there. Again, I'm rectifying. Again, weakness will be there. Again, I'm rectifying. I like that. I'm trying to reduce my total number of weakness to reach 0 in the subject. Automatically, weakness is 0 means strong subject only, right? So these are the different way of learning. Learning, similarly, machine learning also. That is one way of pattern. This is one way of pattern. Is that clear? Yes. Can you explain how the gradient boost is used in case of classification once again? Yes. Classification, in the classification, what happens means first decision tree is created. Okay. Decision tree number 1 is created. And for the decision tree number 1, you have predicted the y hat also. Up to here, it is common. Y is there and you have predicted using the decision tree y hat, common. Done. Now, after predicting, in this misclassification records are there, right? Now you are calculating what is the misclassification rate. You are calculating the misclassification rate. And whatever the misclassification rate is there, you are focusing on this one. Earlier in the regression problem, what you have focused? You have focused on the y minus y hat and you have calculated the MSE. You try to reduce this MSE to the minimum. Now you are trying to reduce the misclassification rate to the minimum. Is that clear? So that is the difference between this regressor versus classification. In this case, you are trying to reduce the misclassification rate. Here it is MSE. So what is the loss function? What is the loss function or cost function for the regression means? The loss function or cost function for the regression is MSE. MSE or RMSE. Whereas the same cost function or loss function for the classification, what is the loss function means? Loss function means nothing but error. Error for the classification is nothing but misclassification rate. You are trying to reduce the misclassification rate. Now, once the misclassification rate was reduced, slowly one by one, you are trying to reduce the errors. So first decision tree, you are calculating the residuals, and second decision tree was made based on the errors of the first decision tree. And like this, you are going to continue, and you are focusing on the residuals. Residuals means nothing but errors. You are trying to reduce the errors. Now, next one is XGBoost. Now, what is meant by XZ? XZ means X means extreme. G means gradient. extreme gradient boost. Okay, extreme gradient boost. Miss gradient boost already you know. Now for that they have added the word called as extreme. Now what is this word meaning is adding the regularization. You are adding the regularization is called as extreme. Nothing else. Just in one word. Adding the regularization to the gradient boost is called as XGBoost. Means XGBoost is also called as regularized. XGBoost is also called as regularized gradient boost. Just you are applying the regularization. That what is meant by regularization? Lasso regression or ridge regression. Applying the lasso or ridge regression. Why we have to apply that one? In order to reduce the overfitting problem. Just XGBoost is a regularization boost. So it is going to add the regularization parameter, and it is also called as regularized boosting. So just you are adding the some kind of this one, and in order to reduce the overfitting problem. The gradient boost is having some kind of overfitting problem. That one also will be reduced in the XGBoost. Same pruning, no difference. In the pruning, there is no difference. Everything is same. Now, the advantage with the XGBoost is it will automatically handle the missing data. If any missing data is there, generally for all the algorithms, if there are missing values are there, we have filled the missing values or we have deleted the missing values. Either drop NA or replace the missing values, that is fill NA. Either we have used drop NA or fill NA, the missing values. Here in the XGBoost, it automatically takes. If you don't clean the data also, it will only automatically do. How it is going to do is it is going to drop. Simply it is going to drop. Okay, it is efficient in handling of missing data miss. If you forget to clean the data, automatically it will only do. And it is having inbuilt cross-validation capability. While creating itself, it has, and it is a parallelized tree building. Now the question is parallel. Sir, you told that boosting means sequential learning. Now, how it is a parallel sequential learning, right? Now, in your system, okay, in your laptop or desktop, your system will have the processor. Some processor is there. Processor might be i3, the processor might be i5, the processor might be i7, anything. But it is having certain cores are there. It will have some cores. Okay, either it is a dual core or whether it is a with respect to quad core or whether it is a hexa core, whether it is a octa core. Cores means dual core means number of cores. Dual core means you are having 2 cores. Then it is called as dual core. And quad core means if you are having 4 cores, then it is called as quad core. If you are having 6 cores, then it is called as hexa core. If you are having 8 cores, then it is called as octa cores. Now, what is meant by this cores and what is the use of this one? Sir, mine is a i5 laptop. Whether it is i5, within the i5 quad core is available, within the i5 hexa is available, within the i5 octa also available. Now, within i5 only everything is available. Now, here, what is meant by this core? Core means which will process the things, which will do the processing. Now, here in your laptop, for example, my laptop, what are the laptop presently I am working is a quad core processor. Sir, how I can know whether how many cores are there in my laptop means just you can check. Okay, just you can check the task manager. In the task manager, here you can click on the performance. In the performance, you can see here total how many number of cores are there. Okay, you can see here number of cores is equal to 4. Mine is a quad core processor. Whatever the present laptop I am working is a quad core processor, which is having the 4 cores. Now, more number of cores are there means cost will be more. Octa core, same, mine is present i7 laptop with quad core processor. Now, if you go with the same i7 with octa core, the cost will be around 2.5 lakhs approximately. The laptop cost will be as the more number of cores increases. But i7 only. i7 is common. Within the I7, if you increase the number of cores, automatically the cost will be increased. As a data scientist, we require the more number of cores instead of graphics card. We are not working on the gaming part or this one, right? So we require with respect to high-end processor, which is having more number of cores. Now, what is meant by cores? Cores means, for example, I'm having 4 cores. If you observe here, I'm having number of cores are 4. But in my system, it will work only 1. As of now, only 1 core is working. Because nothing is working, nothing I'm working now. Not heavily I'm working, right? Nothing heavily I'm working. I have, what are the things I have opened is, one is Google Chrome, one is PDF, and one is Jupyter Notebook I have launched. Only these 3 are working in the backend. So for these 3, 1 core is sufficient. PDF or Excel sheet or Google Chrome, or if you're watching YouTube videos, single core is sufficient. Now, when I'm working on the XGBoost, what happens means automatically XGBoost, whatever the number of cores are there, it will spread the data into all the cores. Every core will work. What happens like that? If every core is working means fast processing. You are having with respect to fast processing. Now, the data will be very fastly, it will be processed. So since it is having with respect to the capability where all the cores can be involved in that, so they have created this one as a separate library. XGBoost is a separate library. It is not in the sklearn, because sklearn will not support that one. sklearn library was designed with having certain things only. It is not going to support. The computational power of sklearn is different. The computational of XGBoost is different. The computational power of artificial intelligence is different. When I explain the neural networks, at the time you observe, it will be different. Right? Now, so here, the advantages of XGBoost is it is going to reduce the overfitting by applying the regularization. Is that clear, guys? Now, if anyone asks in the interview, can you explain what is meant by XGBoost? Sir, XGBoost is nothing but applying the regularization on the gradient boost. Now, where the gradient boost is nothing but a combination of multiple decision trees, where the decision trees are, each decision tree is pruned with a maximum number of leaf nodes between 8 to 32. And by combining all the leaf nodes, we are trying to reduce the error. That is called as gradient boost. In the gradient boost, instead of focusing on a normal error plus lasso, that is with respect to regularization parameter, that is penalty term also, along with your original value, penalty term, overall it should be minimum. Overall it should be minimum. That will be worked in the XGBoost. Is that clear, guys? Just you are adding the penalty term. In your loss function, you are adding the penalty term. What is the difference between linear regression versus lasso regression? What is the difference between linear regression versus lasso? What is the difference? If someone asks you a question, what is the difference? So the loss function in the linear regression is sigma of y minus y hat whole square. In the lasso regression, the loss function is sigma of y minus y hat whole square plus alpha into modulus of slope. That is the loss function. Remaining everything is same. Only the loss function is different. Similarly, what is the difference between gradient boost and XGBoost? Means the loss function of the gradient boost, first penalty term. You are adding the penalty term. By default, it is going to take lasso. By default, it will take the lasso. You can change that one in the hyperparameter tuning by giving L1 and L2. L1 means lasso, L2 means ridge. Is that clear, guys? So let's do the coding part. Coding is important, theory also important, and because if the theory is clear, then you can understand which type of hyperparameters has to be used and what is the maximum number of numbers we can use. Without understanding the theory part, only coding, you can't, it is not going to support. In the interview, you can't sustain. After that, when in the company, why this one they're applying also, we don't know, because we are focusing only on the coding now. Theory, we don't know, right? Then we don't know why they have applied this one. What is the logic behind that? But now you'll understand the theory at the same time. The coding also will be very clear for you. And after the class, just check the interview questions. Whatever the interview questions you are having, check the interview questions. Okay. So this is the same whatever we have done in the last class, that is ADA Boost. I think in the ADA Boost STS coding part I have uploaded and you have practiced the ADA Boost, the same thing. So here also I'm going to work on the same. Once again, the same mushroom data. I'm going to consider the same mushroom data. Again, I'm going to have the same number of input columns and same value counts. All the 22 input futures are discrete variables only. And I'm going to take with respect to same class. And what are the data pre-processing I have done in the STS class? Same data pre-processing I'm going to do. No difference in the data pre-processing. After that, the 22 columns are converted to 95 columns. STS class also 22 columns are converted to 95 columns. Now, once it is done, now I'm going to consider the X variable, whatever the X variable is there, and I'm going to consider the Y variable. This is the Y variable. Once I have considered the X variable and Y variable, I'm going to divide the train test split. After train test split, my X train data of gradient boost, X train data of ADA Boost is same. Now you might get a question. Sir, why you have considered the mushroom data set once again? You can take another data set now. Why you are taking the same mushroom data? If you take the same data, then only you can observe what is the difference between the ADA Boost versus gradient boost. I want to compare ADA Boost, gradient boost. If I want to compare these one, remaining other parameters should be constant. Now remaining everything are constant means now I can show you the difference, exactly what is the difference between the ADA Boost and gradient boost. If parameters are different means automatically everything will be different. So I want to make a comparison between the boosting techniques, ADA Boost versus gradient boost versus XGBoost. What is the difference? So that is the reason I have considered the same data set for 3 of them, so that I can see the difference clearly, how it is working. One will give a different accuracy, one will give a different accuracy, so that I can understand how it is working. The difference I can understand clearly. Now here, from sklearn.assemble, I'm going to import the gradient boost classifier. And once I have imported the gradient boost classifier, I'm going to predict on the X-train, predict on X-test, and I'm going to calculate the accuracy score, train accuracy, test accuracy, and CV. Same to same in the ADA Boost, whatever we have done. In the last class in the ADA Boost, after doing the default model, next what we have done? After that, hyperparameter tuning. So we have to do the same hyperparameter tuning. Now this time, whatever the hyperparameter tuning is there, same grid search CV, estimator is equal to gradient boost classifier. In the ADA Boost classifier, it is ADA Boost classifier, here gradient boost classifier, and param grid is equal to n estimators. Now by default, what is the number of estimators? If you observe here, what is the by default n estimators? N estimators by default is equal to 100. By default, it is 100. Now what I'm going to do is I'm going to try with a 1 to 100. In between 1 to 100 only, I can get any better one. So for 1 to 100, what I have to give here? List of range of 1 to 101. If I give list of range of 1 to 101, total how many models it is going to create? 100 models it is going to create by 1, 2, 3, 4, 5, 6 like this. So it is getting so much of time. It is taking so much of time. Instead of that, I have taken a list of 1, 5, 10, 20. Why I have taken this list? Why I have taken these 4 values only? Why I have not considered other values? Means just for a simple explanation so that you'll understand the concept. If you take the, I can take instead of writing this one, okay, instead of writing this list, if I write list of range of 1 to 101, if I write like this, what happens means it is going to take so much of time. In order to reduce the time only in the class to reduce the time, I have taken a list. I'm trying with 4, 1. Okay, 4 different values. Instead of trying with 100 values, I'm trying only with 4 values. And learning rate is equal to 0.1 to 1. Now, what is meant by learning rate? From each decision tree, how much you are going to learn? How much you are learning from the each decision tree, that is called as learning rate. Sir, what is meant by that? By default, if you don't give anything, from first decision tree, it is going to learn the entire things. Now, what is meant by learning entire things? Means whatever the answer you have got, you are considering the entire answer as it is. Now, by learning rate, what you are doing means your error. or whatever the prediction answer is there, that you are going to scale down, that you are going to reduce. By the learning rate, what happens means the errors you are going to scale. Now, from the first one, you are going to learn only 0.1, means 10% you are going to learn. The learning rate will be constant from across the decision tree models. First decision tree, if you are learning 10%, means second decision tree also 10%, third decision tree also 10%, like that. Just you are applying the scaling. The meaning is scaling. Okay. Now, here, once it is done, now I'm identifying the which is the best parameter. Once best parameters I have identified, now what it is going to do? 1, 2, 3, 4. 4. 1, 2, 3, 4, 5, 6. 4 into 6. Total 26, 24 models it is going to create. First model will be created between 1 versus 0.1. Second model 1 versus 0.2. Third model 1 versus 0.3. Fourth one 1 versus 0.5. 1 versus 0.8. 1 and by considering 1. Okay. Second 5 0.1. 5 0.2. 5 0.3. Like this, it is going to apply total 24 models. Out of 24 models, it has given me the learning rate of 0.8 with n estimators of 10 is the best one, best combination it seems. And I'm identifying the what are the future importances. In this future importances, if you observe, some this one is 1.77 into e to the power of minus 4. That is 10 to the power of minus 4. 10 to the power of minus 4 means 0.001744. This is the one. It is not even having 1% importance also. Not even 1%. This is, what is this one? 0 into 10 to the power of 0. What is the answer? 0 only. It is 0. This is 0. This is 0. This is 0. This is 1.6 into 10 to the power of minus 3. Means it is having 1.6% importance. Right? Now, like this, if you take this one and if I substitute here, okay, I'm having the values like this. Now here, what I'm going to do is I'm going to consider the hyperparameter in futures, which is having more than 0.01. 0.01 means which is having more than 1% importance. Which is having more than 1% importance. Now, if you observe, these are the columns. Now, using these columns, first I'm going to create a list. Okay, yesterday also we have done the same. And using the list, we have created the important parameters. Now, earlier you are having 95 columns. Now you are having only 7 columns. Now, using the 7 columns and whatever the n estimators we have got. What is the n estimators? Best one is 10 with learning rate of 0.8. Use the same thing. N estimators of 10 with learning rate of 0.8 and create the model. Now you can see with respect to train accuracy, test accuracy, and CV score. Now, earlier, if you observe here, what is the train accuracy, test accuracy, and CV? Train is 99, test is 99, CV is 91. CV is 91 means it is not performing. The CV is not equal to tester. This is not a good model. Now, you try to get the betterization, but after trying the betterization also, still you are not able to get the better model. Again, you are getting still only 91%. Now, for this mushroom data, ADA gradient boost is not properly working. So, gradient boost you have to ignore. You have to, yesterday we have applied the ADA boost. ADA boost has given the better result. So, for this data set, ADA boost is better than the gradient boost. Yes, by changing the random state also you can try. Okay. So, what are the random state, yesterday's one and today's one random state I'm keeping common. Based on that, I'm going to work. First, you are going to identify the best random state number. Already you know how to calculate the best random state number, right? Next, XGBoost. Now, if you take the XGBoost. Okay. Now, I'm going to take the XGBoost. Now, first, XGBoost is a separate library. So, you have to install the XGBoost. So, pip install XGBoost. You have to write the pip install XGBoost and you have to install the separately the XGBoost. And you are going to do the same to same coding part and you are going to do the training and you are going to split and finally you are going to get same number of records, that is 95 columns. Once again, you are going to get the same 95 columns. There is no difference in the data. Now, first you are going to start the default parameters. There is no difference in the data pre-processing, guys. Whatever the data pre-processing you have done in the ADA boost, gradient boost and XGBoost, everything is same. Sir, in real life, we have to take a separate Jupyter notebook. It means no need. I have created in the separate Jupyter notebooks, but you have to create in the single Jupyter notebook only. In the single Jupyter notebook only, you complete the first data pre-processing and up to train test split. For that, you apply the grade ADA boost and hyperparameter tuning and rebuild the ADA boost. With that, ADA boost is completed. Now gradient boost, hyperparameter tuning and rebuild the gradient boost. The gradient boost is completed. Next, XGBoost. XGBoost, default model, hyperparameter tuned model and best model. Again, you are going to rebuild the model. Common. Everything is common. See, yesterday's just here what we have done. First default model we have done. After default model, what we have done? Grid search CV and identify the important hyperparameters. After that, what we have done? Future importances. Using the future importances, we identified the important futures. So to be right, can I write the steps like this? First one is default model. Step number 1. After that, grid search CV. Grid search CV, identify the second step. Identify best hyperparameters. Identify best hyperparameters by using the grid search CV. Grid search CV is the function name in the Python. Concept is called as identifying the best parameters. And once we identify the best hyperparameters, now I'm identifying the future important futures. How I am identifying the important futures? By using the future dot importances. I'm identifying the important futures. Identify the important futures. How you are going to identify important futures? By writing here future underscore importances. You are identifying the important futures. Once you identified the best hyperparameters, once you identified the important futures, both of them, once both of them are completed, now what you are going to do? Rebuild model with best hyperparameters with important futures. By removing the unimportant futures, only by considering important futures. By only important futures with best hyperparameters. These are the things. Now, if you observe in the last class, let me open here. First, what is in the random forest? I'm clicking on the random forest. I'm clicking on the ADA boost. Okay, just observe. 4 steps. These 4 steps only will be there. Everything will be the 4 steps. In the random forest, observe the random forest. Don't observe the data pre-processing. The data pre-processing is entirely different. So first, default model. This is the entire default model. Next, hyperparameter tuning. Second step of hyperparameter tuning. Third step, important futures. That is future underscore importances. Identified important futures, and you have rebuilt the model. This is the random forest which we have done. In the STS class, ADA boost. What is the modeling we have done? Just observe the modeling. First, default parameters. After the default parameters, hyperparameter tuning, grid search CV. After that, future importances. Once future importances are completed, next, what is the next step you have done? Rebuild the model with best hyperparameters with important futures. Same to same, right? Next, today's gradient boost. Just observe in the gradient boost. First, default model. Okay. After the default model, best hyperparameters. Once this is also completed, future importances. Once future importances are completed, next you have using that rebuild the model with important futures along with the important hyperparameters. Same thing. And now XGBoost. XGBoost default parameters. And after that, you are going to calculate the hyperparameter tuning. And once hyperparameter tuning is done, you are identifying which is the best parameter and future importances. And once the future importances are done, you are identifying the important futures and using your important futures and with respect to best hyperparameters. What are the best hyperparameters are there? Using your best hyperparameters and along with the important features, you are going to rebuild the model. XGBoost with the best hyperparameters and important features. One more time. Same to same. No difference. Everything is same. Everything will consist of only the 4 steps. Default model, identify best parameters, identify the best features, and build, rebuild. Is that clear, guys? So here, if you observe this one, let me explain this. XGBoost. What are the XGBoost is there? I'm going to do the train accuracy, test accuracy, and cross validation score. Once default model is completed, next what I'm going to do? Hyperparameter tuning. And in the hyperparameter tuning, by applying the grid fit on X train, Y train. Now, what are the hyperparameters should be considered in XGBoost? What is the hyperparameters we have to consider in the XGBoost? 1, N estimators. 2, maximum depth, that is pruning. 3, gamma. Now, what is meant by gamma? Gamma is nothing but alpha into modulus of slope we'll do, right? This alpha here, it is called as gamma. In XGBoost, it is called as gamma, which is nothing but alpha, because you are adding the penalty term now. Penalty term, which is regression. For that, we require the sum, this alpha, right? In a lasso regression, do you remember? If you remember the lasso, this is easy. If you forget that one and everything, if you are forgetting before things, automatically this advanced part will be difficult. Clear, guys? Done? Any questions? So these are the hyperparameters. These are the hyperparameters. Using the hyperparameters, now you'll ask me the question, sir, why you consider only these values? Every time I have to consider only these values. This is the most commonly asked question by the students. Sir, whether we have to consider only these values every time, or what we have to consider, not with respect to only these values. Which values you have to consider, miss? With respect to gamma. For gamma, what is the minimum value and what is the maximum value? 0 is the minimum, and what is the maximum, miss? In terms of with respect to learning rate, will have the maximum value of 1. For gamma miss, which is equal to alpha in lasso. For lasso, what is the maximum alpha? What is the maximum value? There is no maximum value, right? We have tried with different values, same to same. Now, sir, N estimators. What is the list of N estimators I have to give? By default, what is the N estimators you are going to have? You have to take a list of range of. What is the maximum depth I have to give? Before applying the XGBoost for the same data set, first you will apply the decision tree, right? In the decision tree, already you have seen what is the maximum depth, right? And based on that, you are going to give here the values. Is that clear? First, you have to observe the default model, first model and decision tree. And from the decision tree, you have to create the random forest. From that, you have to create AdaBoost, followed by gradient boost, followed by XGBoost. Sir, for creating XGBoost, decision tree is mandatory. Yeah? First, we have to create decision tree. Yes. For example, in the decision tree itself, you have got a better answer. Very good answer in the decision tree itself you have got. Now, what is the use of creating XGBoost? XGBoost will take more time or decision tree will take more time? Can anyone tell me? Which one will take more time? XGBoost will take. Why? Because more number of decision trees are there now. Creating one decision tree is easier. Creating multiple decision trees is easy. One decision tree is easy, right? Now you got the train accuracy 100%, test accuracy 100%, and CV also 100%. In the decision tree itself, you have got that one. Still, you will apply the XGBoost. What is the maximum value? Is 100. 100 you already got in the decision tree itself with the train, test, and CV. Everything 100, 100, 100. If in random forest also, if you get 100, 100, 100 also, there is no use. Because when compared to random forest, decision tree will be done in the less time. If accuracies are same, second priority goes with the time. For example, in the decision tree, you have got train accuracy 100%, test accuracy 94%, which is overfitting problem. Now, then what we are going to do? We are trying with the random forest. In the random forest, you have got the train accuracy 100%. Okay, first let us take like this. decision tree, train accuracy 100%, test accuracy 92%, which has led to the overfitting problem. I'm saying after rebuilding with hyperparameter tuning, after hyperparameter tuning and best model of decision tree, this is the output of the best decision tree. Best random forest has given with 95 and 96, which is not having any overfitting problem. Are you going to stop here? Are you going to stop here? Since there is no decision, there is no overfitting problem, are you going to stop? No. We'll try with AdaBoost also. Why? Why you are trying with AdaBoost? Already 100% and 96. 96 very good accuracy now. Why you will try? Because maybe in AdaBoost we may get 97. Who knows? You know or I know? Unless we apply, we don't know. So then we are going to apply the AdaBoost also. After applying the AdaBoost, 197 I have got. Then I'm going to with AdaBoost. 95 only I have got. Cancel AdaBoost and go with the random forest. So like that, we are going to try with all the techniques, and out of all the techniques which has given the highest accuracy, we are going to see. Sir, for example, let us take like this, sir. AdaBoost has given you 95%. Gradient boost 100% with 96. XGBoost 100% with 96. This is the scenario. Now this one, random forest, gradient boost, XGBoost, 3 of them are same. None of them is giving more than 96. 96 is the upper limit. I have tried all the ways, sir. Whatever the possibilities are there, every possibility I have checked, but never I am getting more than 96. Now what I have to do? In this case, what I have to do? Now, out of whatever you are having, within that, 3 of them accuracies are same, means which will have less time. Out of 3, which will have less time? That one we are going to consider. If accuracies are same, for example, this one is 98%. Now, directly XGBoost. We will not focus on a random forest and gradient. Sir, here 98% it is giving, but it is taking more time, sir. 98% more time, 96 less time. Now, which one is your priority? 96 with less time, 98 with more time. Which one your priority? Miss 98 with more time only priority, because we require accuracy more. Prediction should be more, because based on your prediction, business is going on. Business is going on means investment is going on. Means some money they are going to dump. So money is there in that. Here accuracy is low means automatically there is a chances of losing the money also. Accuracy is high means there is a high chance to get the profits. Is that clear? So top priority has to be given to the accuracy. Second one, if the accuracies are same, then this. Is that clear, guys? So that is with respect to today's session. And in tomorrow's class, we are going to see how to identify the important futures. That is future selection. Future selection techniques. How to identify the important futures. Sir, already you told now, important futures, we can identify futures dot importances. Already you have told, right? Again, why you are saying tomorrow? You already completed now. These are one of the method of identifying the important futures. This will be done after the modeling. If you want to identify some of the futures which are important or which are unimportant before to the modeling, how we have to do, and what are the various options are there to identify the important futures, everything we are going to see in the tomorrow's class. Now, sir, how then in the real life, which we are going to apply? That one also we have to apply. This one also we have to apply. For example, in your data set, one serial number is there. Are you going to keep the serial number? For your analysis, are you going to keep the serial number column? 1, 2, 3, 4, 5, 6 like this serial number. Are you going to keep that one? No, you are going to remove. For example, you are having the names of the person. Are you going to keep the names of the person and you are going to do the encoding? No, because 10,000 records are there, means 10,000 different persons will be there. For 10,000 people, if you do the encoding, means 10,000 columns will be created, which is unnecessary time waste. There is no use of that. Simply we are going to remove. If the common name is there, means then it is different. If there is no common name, then what is the use of that one? Simply we are going to delete. Is that clear, guys? So that is end of the session for today. and we are going to continue in the tomorrow's class. Combination of